Okay, so this is a little conundrum I was given by one of my math students. I think I figured out the answer, but I'm certainly open to criticism if I've made any kind of mistake on this. So the square is 1 unit long and 1 unit high, and then it's got this big quarter circle in it. So the radius of that quarter circle is obviously 1 unit. Then it's got this half circle in it, so the radius of that half circle is obviously half a unit. So the question is, what is the radius of this circle that just touches both circles on the inside of the big one and the outside of the medium one? Okay, so first thing I realized, these circles have centers, and because an angle, because a tangent, um, a tangent to a circle is perpendicular to the radius. Uh, that means that where it just touches, where both circles must touch each other, must go through the center of both circles. So where they just touch each other, if I draw a line um, that's perpendicular to where they cross, that will go through the center of both circles. And the same applies to the medium circle and the small circle, where these two just touch each other. Um, the line that passes through that is and just touches it also goes through the center of both circles. And then there's another line that I put there where it just touches the vertical here on the side of the square. If I draw a line perpendicular to that, that must go through the center of that circle. So putting some numbers on here, I'm calling the unknown radius r. So that's r, that's r, that's r there, and that's r there. That's 0.5 because it's the radius of the medium circle. And this little bit here is 1 minus 2r because all the way from here where I'm pointing down to here is 1 because it's the radius of the big circle. And then along that line we've got the radius of the small circle twice. So that little stretch there is 1 minus 2r. In fact, the bit I'm going to use later on is going to be from here to here, so from the center of that circle to the center of that circle, and that's just going to be 1 minus r because it's 1 there minus this r. But we'll have a look at that in a minute. Some more numbers that I put in. What have I done here? Okay, yeah, so 0.5 is the radius of the medium circle from there to there. So it's also 0.5 from there to there because it's the radius of the medium circle. Not sure why I've written 0.5 twice. I think that's just a PowerPoint glitch. And then I've taken all of the circles away. And as I'm taking those away, note how this changes to 1 minus 2r, because instead of talking about from here to here, I'm adding in the extra bit here. So 1 minus 2r plus the extra r makes just 1 minus r. And then what I've got is a bunch of right-angled triangles. So a right-angled triangle down here with sides 1 minus r, and then r plus 0.5, r plus 0.5, and then by Pythagoras, the third side of that must be the square root of r plus 0.5 squared minus 1 minus r squared. So that's just Pythagoras, bearing in mind that the r plus 0.5 is the longest side, the hypotenuse. Now I've got another right angled triangle over here, and the same thing again. This squared plus this squared is going to make this squared from Pythagoras. So this must be the square root of 1 minus r squared minus r squared. The square root of this squared minus this squared. Now, the height of this triangle, as we can see, is that expression there. And then the same height over on the other side of the diagram is 0.5 plus this expression here. So those two are the same, 0.5 plus that big square root, and then this other big square root on the left-hand side. They are the same, so they are equal to each other. This equals that plus that. So that's getting towards an equation that looks like it could be solvable to figure out what r is. But I'm a little bit uncomfortable with solving things with square roots on either side. So I'm going to do a little bit of manipulation and a little bit of a tricky thing, which I'll show you in a minute. But first of all, let's tidy this up. So 1 minus r squared, 1 minus r all squared, minus r squared, and then all of that in a square root. So I've just multiplied the brackets out here. So by all means check that that multiplies out correctly, and then the same thing here where I've multiplied these out. So r plus 0.5 all squared give you r squared, and then remember that r plus 0.5 all squared means r plus 0.5 times another r plus 0.5. So we get an r from the first bracket times an r from a second bracket gives you r squared. An r from the first bracket times a 0.5 from the second bracket plus a 0.5 from the first bracket times an r from the second bracket gives you a whole r. And then a 0.5 times a 0.5 gives you 0.25. So I basically multiplied all the brackets out, and then remembering that this minus in front of 1 minus r squared applies to all of it when I multiply it out. And then when I tidy that up a bit, so I've got an r squared, a minus r squared there, got an r squared there, a minus r squared there, so they're all going to cancel. I've got an r and a minus 2r, so that's going to make 3 r's. So you can stop the screen and check all the minor algebra there. But it boils down to 1 minus 2r equals 0.5 plus, the square root of 1 minus 2r equals 0.5 plus the square root of 3r minus 0.75. Okay, well, I find that a little bit tricky to solve, and what I did to try and get around that was to have a little transformation where I said that x squared was going to be 1 minus 2r. So that thing in the square root, I called it x squared, where x is some other quantity that's related to 1 minus 2r. So it's a kind of transformation I've done. So following the algebra through on this, if x squared is 1 minus 2r, then by adding 2r to both sides and subtracting x squared from both sides and dividing both sides by 2, that rearranges into r equals 0.5 times 1 minus x squared. So 3 times that is 1.5 times 1 minus x squared, and 3r minus 0.75 is 1.5 times 1 minus x squared minus 0.75, which simplifies a bit when you multiply it out to 0.75 minus 1.5x squared, Well, why have I done that? Well, and that's because 3r minus 0.75 is this thing in the square root over there. So, if I'm to say that some quantity x squared is 1 minus r squared, then I can replace, well, 1 minus 2r, I should say. If I'm saying that the x squared is 1 minus 2r, then I can replace this 1 minus 2r with x squared. And then on the other side, since I worked out that 3r minus 0.75 will be 0.75 minus 1.5x, I can replace the 3r minus 0.75 with 0.75 minus 1.5x. So why have I done that? Well, it's because the square x in x squared and the square root will cancel each other out to give me a simpler expression that doesn't have a square root in it. So x equals 0.5 plus the square root of 0.75 minus 1.5x squared. Well, I've still got something with a square root in it, but I can deal with that. I'm going to take 0.5 away from both sides to get the bit with the square root on its own. So x minus 0.5 equals that square root. Then I'm going to square both sides. So just so x minus 0.5 equals that square root. Squaring both sides, x minus 0.5 squared is x squared minus x plus 0.25 because x times x gives you the x squared. X times minus 0.5 plus another x in another bracket times minus 0.5 in the other bracket gives you a whole minus x, and 0.5 times 0.5 gives you 0.25. So when I square the left, I get that, and then when I square the right, all that happens is the square root sign disappears. So I've got x squared minus x plus 0.25 equals 0.75 minus 1.5x squared. So I can add and subtract things to both sides to get everything on one side equal to 0. And when I do that, that comes to 2.5x squared minus x minus 0.5 equals 0. If I double everything just to tidy up, get rid of the decimals, that's the same as 5x squared minus 2x minus 1 equals 0. That's just literally everything multiplied by 2 both sides. And that is just a bog standard quadratic that we can solve with the formula. So I'm not going to show all that here, and in fact I just kind of bunged it into a website that does the quadratic formula for you, and it came out to be x equals 1 plus square root of 6 all divided by 5. Being a quadratic, there was another negative solution to that, but in the context of this question I disregarded that. Okay, so x equals 1 plus root 6 all divided by 5. I want to know what r is, because r is the radius of the circle I'm trying to figure out. And I know that x squared equals 1 minus 2r, so I can use that relationship to get this back to an answer that's something with r. Okay, so x squared is that. So I just kind of squared the bottom to get 25, and I multiplied 1 plus root 6 by itself to get 1 plus 2 root 6 plus 6, because 1 times 1 gives me 1. 1 times root 6 plus another 1 times root 6 gives me 2 root 6. And root 6 times root 6 gives me a whole 6. So x squared, squaring the top and the bottom, is that, which I can tidy up a little bit because 1 plus 6 makes 7. So that's the same as x squared equals 7 plus 2 root 6 all divided by 25. But r is 0.5 times 1 minus x squared, as we established above there. So 0.5 times 1 minus x squared is 0.5 times 1 minus that expression there. So I've got a whole number and a fraction there. So what I'm going to do is change the 1 into 25 over 25 so that it's got the same denominator as that. And then r equals 0.5 times 25 25ths minus all of that, which I can write as a single fraction like that. So 25 minus 7 gives me 18, and then minus 2 root 6 minus 2 root 6. So the radius is 0.5 times brackets 18 minus 2 root x all divided by 25. So I can get rid of that 0.5 just by multiplying everything on the top by 0.5. So instead of 18, 9, and instead of 2 root 6, just a single root 6. So that gives me that the radius equals 9 minus root 6 all over 25. There might possibly be a slightly more elegant way of writing that still. Breaking down the root 6 into some smaller square root, but 9 minus square root over root 25 is my final answer. That's about 0.262. And then going all the way back to the beginning of the problem, that sort of certainly seems reasonable. If the radius, if the side of the square is 1, then the diameter of that looks like about half, and the radius of that looks like it's about a quarter. So my final answer of 0.262 is certainly around a quarter. So I hope I haven't made any mistake there, and the answer I've got certainly seems sensible looking back at the original problem.